My dear students, in this machine learning lecture, I will be teaching you hierarchical clustering. It is a method for clustering data points. So here we will be doing this, and so I will explain you one by one the steps. And first of all, we have to import NumPy and import matplotlib. So these two things we have to import. So I will first here explain this. I will comment here, so you can later on refer this. So first of all, hierarchical clustering. So I will write the definition here. String is a method eh, of clustering for data points VOIN for data points where the algorithm. So here I will again make a comment. Algorithm builds the cluster by measuring a, the dissimilarities between the data. The data, three lines we have to make. So in order to make the compiler to draw this, so this is essential thing. We have to make three lines. We have to make lines lines to make our compiler able to draw. Mhm. So I have written here the definition of hierarchical clustering. So now, first of all, what we have to do? There are many steps here. So in the first step, we have to import NumPy. So I will be importing NumPy. Step one, P1. So step one is importing NumPy. Importing necessary libraries. I will write NumPy and even matplotlib. 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 So this two necessary libraries we will import first. So we will use keyword import, import numpy, new mpy numpy as np. So here we can directly import numpy, but I am using it as np because we have to use again and again np numpy. So again and again we have to write numpy. It's very big. So we will just write two words, that is np, wherever numpy will be there required. So here import numpy as np. So this first we have done, and second one we will import matplotlib. Import matplotlib dot pyplot pyplot as plt. So it's better now, instead of writing again and again matplotlib pyplot in every step where it is required. So we will just write plt. So as plt, this as keyword is very helpful. So it reduces the number of words required. So we instead of writing matplotlib everywhere, we can use just plt. So this is the first step we have done. So let's run this first step. So it got successfully imported. These two things got successfully imported. We have to just select this and run this. Now second one we will do. Step two is what we will define the data set and make scatter plot for this here. So step two, define the data and make the scatter SEA plot. So this also I will comment out. Define the data and make the scatter plot. So I will define the data. I will take two parameters. So x equals to, I will make an list. This is called as array in other programming language. In this I will take few values like 4, comma 5, comma 10, comma 4, comma 3, comma 11, comma 14, comma 6, comma 10, comma 12. So this much I have taken for x value, and now this I will make it as 5, and in the y, so array named list named y, we will take so this is tuple. We don't want tuple. We want list, that is array. So 21, comma 19, comma 24, comma 17, comma 16, comma 25, comma 24, comma 22, comma 21, comma 21. So these two we have imported here. Now next one is we will use plot. This what we have imported here na, matplotlib dot pyplot as plt. So we we have taken this as plt. So we will just use here as plt. We are making scatter plot. So we will use dot operator to access scatter. Cater scatter. So for x and y, we will make, now here we need tuple x, comma y. So I will run this code here first. So let's run this code. So you can see output has come. So this is the scatter plot. What we have made here for x axis and y axis. Okay, so you can see on y axis, first one is this, second one is this. So in this way it has made this 4. You can see 4. So 4 here you can see this is the 4 one x axis. So 4 on the x axis is there, and y axis you can see 21. This is 21. This 21 is on the y axis, and in this way we have created this matplotlib. So here pyplot we have done. So step 2 is done now, and now next one we will do. So this one we have done. Now next step is our, we have to find Euclidean distance formula to measure the distance. So in mathematics we can do it using the formula is there. So but here this Python code it automatically does everything. So it becomes easier for us. So let's make Euclidean distance. Okay. In this step, I have told you we will actually find the Euclidean distance formula. So distance between the 2 points like this. So and we will use dendrogram. We will input dendrogram and we will visualize the data. So let's first I will comment here. Euclidean distance formula. Distance formula will be used to measure measure the distance distance distance, and we will import dendrogram to visualize the data. We will we will import Dendrogram. This is our library in the Python. Dendrogram to visualize the data. To VISU the DAT data. So let's do this. First of all, we will import numpy as np. Import numpy as np. Then second, we will import same thing. Import plot matplotlib matplotlib dot pyplot pyplot splt lt. And third one, we will use SkyPy. So from SkyPy, we need only dendrogram. We can import the whole SkyPy, but it becomes heavy. So we will just import dendrogram from SkyPy. So I will write this keyword from SkyPy, SCI dot cluster, LUS cluster dot hierarchy, HIERARCHY import import dendrogram with linkages. So dendrogram comma import space linkage linkage. So let's run this whole column, this whole cell we will run. So module error. So there is some error, module error. Let's check here what is the problem. Sky numpy is np matplotlib. Oh, pyplot is only pyplot is required. Pyplot by mistake. Here dendrogram, here also matplotlib np matplotlib dot pyplot splt skypy cluster hierarchy. Dendrogram KAT. So import dendrogram, DRO dendrogram linkage, comma linkage. Let's run this. So we have successfully ran that. Actually dendrogram it was by mistake. I forgot to put R in between. So now next step we will, so the result will be displayed. If we will provide whatever the data are required, so result will be displayed. So I will write here. I will first comment here that result will be displayed. RESULT will be displayed displayed. So here I will provide the data what we have provided above. The same data I will copy and paste here. So I will be providing the same list, this two list what was there. So I will just copy and paste here. So as I have pasted here, so I will make one variable called data is equals to. So I will use this list function is there. Yes, the list function, and I will zip this using zip function, inbuilt function in our Python. So zip. Then I will put these two things x and y, x comma y, and then I will do what I want to link this. No? I have taken here linkages. So linkages data I will make one variable called linkage something, linkage 1, linkage 2, or linkage data, nkage underscore data is equals to. So this what I have imported, this same thing linkage. So I will use linkage Linkage, linkage. Then here in this I will put, so this inbuilt function linkage is there. We have imported it. So I will put three parameters I will put. First is data. First is means this is the first parameter that it has taken. It has taken this list parameter and zip parameter, and here it will put in this function linkage inbuilt function, and then I will put method. So then here I will put ward, WARD. So this parameter is already defined, so it cannot be changed. Ward. So metric also, metric. So I have defined here. So three parameters I have defined here. So the third one is Euclidean. Euclidean. DEAN. Euclidean. Metric Euclidean. So these three I have taken here. So now I will use dendrogram to actually display, visualize the data. So dendrogram, dendrogram. Then I will use the linkage data. This whole thing I want to display. This variable I will copy as it is and I will put here in this. And I want to show that. So I have imported plot now. So I will use PLT to show that. So inbuilt parameter for our Python library. So inside this now I will be running this code. So some error is there. Method O. METHOD method word. Now let's rerun this. Yeah. So you can see it has actually created this whole thing, and it has linkages also. It has shown the distance from here to here like this. Whatever that points were then here, here, here. So it has shown the linkages. So in this way, I have shown the linkages for this one. So as you must have understood how we can use this. Later on, I will explain the theory about hierarchical clustering, what it clearly does. But this was the practical session. So you must have understood the steps. So first step is importing the necessary library. Second is define the data in a list. So we will use scatter plot. So it will scatter the data like this. And third one is we will find the distance between the points using Euclidean distance formula. So and we will use dendrogram. So dendrogram will actually display that. So result is displayed like this, and we have used this list and zip function to put this to array, and then it has given this. And here three parameters we have passed in this inbuilt function linkage. So like this we have found out. So this is how we can do. So you can go through this first step, second step, third step, then fourth step Euclidean distance formula, then fifth step is this, and last one linkage is from here. So thanks for watching my video. It has been great that you people have watched my video.